In this week's Multiple Choice Monday, we are looking at shapes of molecules, but in particular, looking at organic molecules and longer molecules where there's more than one bond angle. So usually when we start to learn about bond angles, we often just focus on molecules that just have the one central atom, rather than appreciating, of course, with something of an organic molecule, there's going to be bond angles around all of the atoms along the chain. And so it can help, rather than sitting and trying to work out everything individually to get our answer, which was B, we can think about the possible combinations that we can get with organic molecules and therefore think about some shortcuts to identifying bond angles. So organic molecules are going to be containing carbon, hydrogen, oxygen and nitrogen for the most part, and very rarely any other atoms. Hydrogen is never going to be a central atom. Hydrogen is always going to be attached to the outside, so we don't need to worry about that. So we really are only looking at combinations of carbon, oxygen and nitrogen and the hydrogen atoms and seeing how they're bonded together. So if we look at nitrogen first of all, then the possibilities for nitrogen is that most of the time it's going to form 3 bonds and 1 lone pair. And so there's always usually going to be therefore a trigonal pyramidal shape around my nitrogen, and it's going to have a bond angle of 107 degrees. Now, there is nitrogen when it's attached to carbon in CN as it is in B, and we'll come to that in a moment. But for anything, for example, where we see NH2, that is going to tell me that it's 107 degrees. I don't need to sit and work that out. Then let's look at our oxygen. So oxygen is usually going to be in an OH group, which means it's going to be bonded to a hydrogen and then bonded to a carbon, which means it's going to have 2 bonds and 2 lone pairs, and is going to have a bond angle of 104.5 degrees. So for that, we're talking about an alcohol group, an OH group, or indeed an ester where you've got your single bonded O. So that will have a very predictable bond angle. Then let's look at carbon. Now carbon, of course, can form multiple bonds, which gives it a little bit more flexibility. And let's look at carbon in the way that it could be bonded. So carbon has the option of forming 4 single bonds, which is our 109.5 degrees. Carbon is never going to have a lone pair, so it's never going to form 107 and 104.5. But it can form a double bond and 2 singles, and so where you're going to see that is either in a CO carbonyl group or in an alkene, and that's going to give us our 120. And to get 180, well, that's very challenging in organic chemistry because 180 normally just means 2 bonds or 2 areas of electron density, which is quite uncommon. However, in the CN group, we have a C triple bonded to a nitrogen. That's how the nitrogen can be on the end of the molecule, and then only singly bonded to the rest of the carbon chain. So in a nitrile, that is going to be 180 degrees, and that's the only place other than a C triple bond to C. So that's my other option. An alkyne, super rare, much more rare than a nitrile. So that means that I can basically look along the molecule. If I see CH3, CH2, all of those are going to be 109.5. I then see an NH2 for A, and that's going to be 107. Looking at B, CH3, 109. CO, there's a double bond there, that's 120. CH2, 109.5. CN, 180. Just looking at the others so that we get the hang of how you do this. CH2 at the end of a chain means double bond because there's not enough hydrogens there for it to be singly bonded. So we have 120 degrees around the first 2 carbons in C. Then we have a normal CH2 in the middle of a chain, 109.5, and then we have another 20 because of the aldehyde group, C double bond O with an H at the end. And then with D, we would have 109.5, CH and an OH, so that's actually just a normal tetrahedral carbon with 4 things attached, and then a CN with 180 at the end. So if you would like a bit more help, do be aware if you're in year 12 going into year 13 next year, I've got a free webinar on the 4th of July on calculations in A-level chemistry. You may have noticed a lot of calculations this year. They are going to be even more important in year 13. That's free, but it is limited sign-up options. So message me, email me, claire@ckchemistry.co.uk to get your space on that. And of course, there are still questions and explainer videos on my website.